All right, so now we are going to be creating different types of parallelograms on the coordinate grid. For example, number 6, we want to complete each of these shapes to create parallelograms. And in number 7, we're going to create a rhombus without making that rhombus into a square. So let's get started. Number 6, there's 3 different ways that we can create parallelograms here, and we're going to determine all the possible different ways. So one of the ways is if I connected my 3 dots that were given to us like this. And so in order to continue the parallelogram, let's look at the slopes. So the slope from this point here to the top point would be 1, 2, 3, 4. And over 2. So if I go down 1, 2, 3, 4 and over 2 this way, that would give me my other point on this quadrilateral to make it a parallelogram, because then those 2 opposite sides are parallel there. So I can place a point at 1, -1 to finish off this parallelogram, and it would look like this. All right, so the next one, what if I connected, instead of connecting my 3 points in the way that I already had connected, what if I connected my 3 points like this? So what I would want to do here is I would again want to look at the slopes. So the slope from this point to the top point is up 1, 2, 3, 4 and over 2. So I can do the same slope using this point going up 1, 2, 3, 4 and over 2 this way, because then that would give me 2 parallel sides like this. So that puts me at the point 5, 7, and it makes the opposite sides parallel. So finishing off that parallelogram, it looks like this. All right, lastly, there's another way that I can connect all 4 of these points here, or all 3 of these points here. I can connect them this way. And then I can use opposite reciprocal, or not opposite reciprocal slopes. Now I can use slopes to determine my 4th point. From this point to the top point, my slope is up 2 and over 1, 2, 3, 4. So going from this point here and going up 1, 2 and over 1, 2, 3, 4. If I place a point here and connect these 2 points together, those 2 opposite sides are parallel, thus making this a parallelogram, putting that last point at the point -7, 3. All right, now the next problem, I have opposite vertices of a rhombus at -5, 7. And 3, 5, -5. And I want to find the other 2 vertices without making this rhombus into a square. Now what we do know about a rhombus is that the midpoints of the diagonals are going to be the same because diagonals of a rhombus bisect each other. So I'm going to find the midpoint of diagonal AC. So the midpoint formula is I take x plus x and I divide it by 2, and then I take y plus y and divide it by 2. And so this gives me a midpoint of -1, 1. So let's plot that point, -1, 1. This is the midpoint of my diagonal AC. It is also going to be the midpoint of my other diagonal. Another thing that we know is the diagonals of a rhombus are not congruent. If they were congruent, then it would be a square, and we don't want to make this rhombus into a square. So we also know that the diagonals are perpendicular, so let's use slopes. If I find the slope from my midpoint of my diagonal to A, I go up 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4. So a negative 4 gives me a slope of diagonal AC as a negative 3 has when I simplify. So I want the slope of, I'm going to call it diagonal BD. I want that slope to be a positive 2/3, the opposite reciprocal, because then that would make the diagonals congruent. Or not congruent, sorry, the diagonals perpendicular. Now I don't want the diagonals to be congruent, but I'm going to go ahead and from my midpoint, I'm going to use a slope of up 2 and over 3. Now if I put point D or B here, it's actually not going to make this into a rhombus, so I'm going to keep going. Up 2 and over 3. This is also not going to be a rhombus, because that would mean the diagonals would be congruent here. I'm going to go up 2 and over 3 again. And let's try that. Now I'm going to go down 2 and over negative 3. Down 2 and over negative 3. And down 2 and over negative 3. And let's put point D here. Now finishing off this quadrilateral, I have a length of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And this opposite side is also 13. If I connect B to C, we're going to see if this has a length of 13. And same with A to D. Well, using the Pythagorean theorem, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And 1, 2, 3, 4, 5. To finish off my right triangle, I would connect B to C. And this is a Pythagorean triple with BC being a length of 13, which means AD is also going to be 13. So all 4 sides are equal. The diagonals are perpendicular because I found opposite reciprocal slopes. The diagonals bisect each other because they have the same midpoint. And the diagonals are not congruent. So this makes it a rhombus, which means that point B, was at 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. The point 8, 7. And point D was at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, negative 10. 1, 2, 3, 4, 5, negative 5. So those are my 2 points to create my rhombus. All right, that brings us to the end of this lesson.